This is lesson 8.6 part 2. Today we will concentrate on solving quadratic equations using the methods that we've learned prior, which are using the zero product property, and today we will learn a new method known as the square root property. Square root property. To solve a quadratic in the form x squared equals n, where n is greater than or equal to 0, what you must do is take the square root of each side. For example, x squared equals 25. Well, in order to isolate x, because it's being squared, I must do the opposite operation, which would be taking the square root. Whatever I do on one side of the equal sign, I have to do on the other. So the square root of x squared equals the square root of 25. Now we know that the square root of x squared would be x, and the square root of 25 is positive 5 and negative 5. Therefore, this equation has two roots, positive 5 as well as negative 5. Okay, let's look at number 1. Let's work an example out together. X squared minus 16 is equal to 0. Well, what we can do here is we can isolate x squared, if you like. We can say, well, x squared is equal to 16. We did that by adding 16 to both sides. Then let's find the radical of each side. X equals positive 4 and negative 4. So those are the two solutions. Okay, let's go on and do number 2 together. I have y minus 6 squared is equal to 81. Well, here, y minus 6, the entire expression is being squared. So before I can isolate y, I first have to undo that which is causing those parentheses to be there. The parentheses are there because the expression is being squared, so we need to undo that. The opposite of squaring an expression is to find its square root. So, y minus 6 squared, if I find the square root of that, it's y minus 6. And the square root of 81 is positive and negative 9. Well, now we can isolate x by adding 6 on both sides. Y equals 6 plus or minus 9. So there's two scenarios we have to look at. We can look at y equals 6 plus 9, which means y would be 15, and y equals 6 minus 9, which means that y equals negative 3. So the roots of my equation are negative 3 and 15. The solutions are negative 3 and 15. Okay, number 3. X plus 6 squared is equal to 12. Again, we have to find the square root of both sides of this equation. So, on the left, x plus 6 squared, the radical or the square root of that would be x plus 6. And then the square root of 12 would be 3.46, positive and negative. All right, so here are my two scenarios. I have x equals negative 6 plus 3.46, or x equals negative 6 minus 3.46. All right, so here x equals negative 2.54. And here x equals negative 9.46. So those are my two solutions, negative 2.54 and negative 9.46. I encourage you on these square roots to use your calculator and round to the nearest hundredth when you are finding the square root of a number that's not a perfect square. All right, let's go on now. Number 4, I want you to try on your own. Number 4. I have a minus 10 squared is equal to 121. Go ahead and work that out. Hit pause and then check back for your answer. Okay, your solutions are negative 1 and positive 21. Okay, number 5. Do this one on your own as well. Number 5. Z plus 3 squared is equal to 26. Press pause, work this problem out using the square root property. Come back and check your answer. For number 5, the two roots or the two solutions are negative 8.1 and positive 2.1. Number 6, I'll do this one with you. 64 y squared minus 48y plus 18 is equal to 9. So here we need to employ the zero product property. So let's start by making this equation equal to 0, subtracting 9 from both sides. 64y squared minus 48y plus 9 is equal to 0. So I need to factor the expression, the quadratic, and as I look closely I realize my first term is a perfect square, my last term is a perfect square. The square root of the first term is 8y. The square root of the second term is 3. When I multiply 8y times 3, I get 24y. Double that, it checks out. This is a perfect square trinomial. It's 48y. Therefore, I can use the pattern to solve this. So, I have 8y minus 3 there. Okay, so now I need to isolate y. So let's work on finding the radical on both sides. Okay, here we go. 8y minus 3 is equal to 0. 8y is equal to 3. Therefore, y is equal to 3/8. In this case, we only have one solution or one root. Okay, number 7. Try this one on your own. 25a squared minus 40a equals negative 16. Press pause now, work this out, and then check your answer. Okay, there's only one root or one solution to this quadratic equation, and that is 4/5. Okay, so tomorrow we will continue working on solving quadratic equations using the square root property. This is the last lesson of this chapter, so we should be having a chapter test very soon. God bless you. Be ready for tomorrow with any questions you might have. Good night.